And one more thing you have to remember the most is the names of groups. Okay, so here 1A group elements, there is a special name for the 1A group elements and 2A group elements. Similarly 60A, 50A group elements, 60A group, 70A group and 80A group, all these elements have some sort of special names based upon their characteristics, based upon their origination, like that. See, for example, if you consider the 1A group elements, these 1A group elements are derived from plant ashes. So when the plant is burned, the remaining ash will be. So these elements are derived from the plant ashes, and so they are called, the plant ash is nothing but alkali. Hence these are called alkali metals. These are called alkali metals. And similarly this one, these are called alkaline earth metals. And there is another name for alkali. Alkali is nothing but the base which is dissolved, which is able to dissolve in water. So all these metals form bases, and these metals, the metals of these the bases of these metals are soluble in water. Hence these are also called as alkali metals, except there is an exception for this case, because according to modern periodic table, the modern periodic table was classified on the basis of atomic number as well as the electronic configurations. But here hydrogen is not a metal, it's a simply non-metal. The properties of hydrogen is entirely different from the rest of the elements in the 1A group elements. So hydrogen is not an alkali metal, you should remember this point. As well as francium is an alkali metal, but it is not originated from the plant ashes because it is radioactive element. We know that the elements after bismuth, the atomic number of bismuth is 83. After bismuth, it means polonium. The radioactivity, the property of radioactivity will start from the element polonium. Okay, so francium is obviously after polonium. Hence if the radioactivity starts from this point, francium is obviously a radioactive element. All the radioactive elements are having different properties when compared to the non-radioactive elements like any other, say gallium, aluminum, carbon, magnesium, boron, silicon, like that. Okay, so you have to remember these names very well. Alkali metals, 1A group is called alkali metals, 2A group is nothing but alkaline earth metals, and there is no special name for this 3rd A group and 4th A group. It is named after the first element in the particular group. So here the first element is boron, hence 3A group is called boron family. And similarly 4th A group elements, the first element is carbon, so 4th A group is nothing but carbon family. And for the 50A group elements, the first element is nitrogen, hence it is nitrogen family. Nitrogen family. See, if you observe any of the hydrides of nitrogen family, say ammonia, NH3, I think you pretty well know about ammonia, which is very much smelly and it causes suffocation. We cannot breathe in the presence of ammonia. It is highly dangerous. It may be fatal to you. So there is no chance of breathing in the presence of the hydrides of 50A group elements. They cause suffocation. So suffocation, they create suffocation, hence they are called nicogens. They are called nicogens. Nico means suffocation, gen means creation or formation. So they create suffocation, hence the 50A group elements are called nicogens. Okay, and coming to 60A group element, the 60A group element, the first element is oxygen, hence this family can be called as oxygen family. And oxygen family, the elements of oxygen family has an ability to form the ores. Hence the elements of this particular family are called chalcogens. Gen means formation, chalco means ore, hence these are ore forming elements, hence they are called chalcogens. And coming to 7th A group element, the 7th A group elements are called halogens, because halo means the salt which was derived from the seawater. You pretty well know about NaCl, sodium chloride. So sodium chloride is derived from seawater, which is abundant in nature. The main content is sodium. Other than sodium, there is chlorine. So these elements are highly available in the salts which are derived from the seawater. So halo means salt derived from seawater, as they forms salts which can be derived from seawater, they are called halogens. And coming to 8th A group elements, 8th A group elements have different names. They have a lot of names because every element in the periodic table tries to attain the configuration of these elements, because these are highly stable in nature. These are highly stable in nature. If they have enough stability, there is no need of participation in the chemical reactions. If there is no need of participating in chemical reactions, they doesn't transfer or share any electrons from them. So they have octet configuration in their outermost orbit, as we discussed this particular point in the atomic structure chapter. So all these elements will have outermost electrons, number 8 electrons in the outermost orbit, except helium. Helium has only 2 electrons. All these will have octet configuration. Octet configuration in the sense having 8 electrons in the outermost orbit. And coming to helium, helium has duplet configuration. So this word is pretty much, unfamiliar, because it has only 2 electrons, and that particular configuration is called duplet configuration. It was written in very less books. According to our board syllabus, there is no word called duplet, but octet is very much famous. Okay, so as they have 8 electrons in the outermost orbit, the valency of these elements is always 0. Hence the 8th A group are called 0 group elements. They doesn't participate in the chemical reactions. It means they have inert nature. Hence they are called inert gases. Stable elements, rare gases. So all these names belongs to 8th A group. Okay. So now we should remember another thing, which is valence electrons of these elements. So what is valence? What do you mean by valence electrons? In the atomic structure chapter, we have discussed about valence shell. Valence shell is nothing but, don't get confused, clearly valence shell is nothing but the outermost orbit of an atom. Okay, outermost orbit of an atom can be called as valence shell or valence orbit. The number of electrons present in the valence shell, the number of electrons present in the valence shell are called as valence electrons. So here, if you observe 1A group, all the 1A group elements will have only 1 electron in their outermost orbit. They have only 1 electron in their outermost orbit. So for here I am writing it. So for 1A group elements, the number of valence electrons, it is 1. For 2A group, the number of valence electrons, 2. For 3A group, the number of valence electrons, 3. For 4A, I think you have got the trend, the number of valence electrons in 4A group, obviously 4. 5A group, 5. 6A group, 6. 7A group, 7. And 8A group, 8. So these are the number of valence electrons in the outermost shell. You should remember this number of valence electrons because we have a lot of work with this.